Hey y'all, this is Noah, aka Stan's Revenge. This is our 100th episode. I don't know how we got here, but man, we've made a ton of progress, and this season's just been more exciting than ever. And you guys motivate me to keep recording, keep posting videos, keep at it on this process and this project. And I just want to thank you guys again for the likes, the subscribes, the comments, getting in touch with me, asking your questions, just helping to fuel that fire of pursuing this technology. And I really think that we're really close to something really cool. And I'm still underground enough to where I'm not a target, so that's cool too. But yeah, just stay tuned. We're going to have a bunch of great videos, especially the ones coming up here, episode 100, 101. We just found some really cool things, and I'm really excited to take this to the next level. We are breaking that 150 volt ceiling, and I feel like we're going to go way beyond that very soon and have some very surprising results. So again, thank you guys for subscribing, liking the videos, keep watching, and there's much more to come. Welcome to Season 4 of Stan's Revenge. A new exciting chapter awaits. My name is Noah Almond. I've been experimenting with Stanley Meyer's water fuel cell technology for over 14 years. In previous seasons, I've made exciting discoveries in its technology, namely the operation of the electrical polarization process. This is unlike traditional DC electrolysis where low voltage and high amperage is utilized. As always, no electrolyte or additives are used in my cells. Only ordinary, natural water is utilized. In this season, I pushed the boundaries of my water fuel cell technology further in my latest attempt to break the glass ceiling of 150 volts. Join me as we unlock the secrets. This is Stan's Revenge. Well, what do we have here? This diode has no connectivity. This diode has connectivity, even in reverse polarity, or this one does not. We've got a dead diode over here. Verified this new diode, and it does not make any connectivity like the other one does here, so definitely dead. Test your components often. It literally cause you so much headache for no reason. You just gotta test your components. You fry them, they may appear to work, but they don't. I've got plenty, so I'm just gonna replace both of them. There we go, and change that up a little bit. So diode back, feeding, diode in from positive input. Snubber connection port. Now we get nothing. Investigating. Noticing that I'm not getting any amp consumption whatsoever, so we got a problem with the primary driver. What I was just working on, yay. There's gotta be something stupid because it was literally just working. Trying to figure out why I have opposite polarity magically on my primary inputs to my driver. Like, what the actual... Why do I have these reversed as far as my positive goes to negative and negative goes to positive in my driver? What was I thinking? How is this even working before? So yeah, I'm going to correct this setup here to it's actually going to receive positive on the positive rail, I guess. I see the errors of my ways. I also think maybe my MOSFET is blown because I'm not getting proper signal to the actual VIC itself. Man, I'm just riddled with issues. This matrix switchboard is almost more work than it's worth. However, it has made troubleshooting quite easy. I'll credit myself to that at least. Big notice here, I think I actually caused my MOSFET to blow up. It probably was just the diode, but since I reconfigured this was connecting down here. This is on the negative rail. This loop back for the snubber needs to loop back to the positive rail, for that to happen. I had it looping to the negative, and that was probably just causing a dead short and just totally frying my MOSFET. We'll find out here. Hold up with us. I think I got a box of MOSFETs here. Yay. Okay, so maybe I'll confirm another video here. I had to switch around the D and S, the red and green on here, drain and source, because I swapped the leads coming in here. That was probably shorting out my MOSFET. Well, initially it was just because of the diode, so I created a whole mess of problems by switching around things, but now things should be in place. We'll see, fingers crossed. Still troubleshooting. If a project goes together really well, it pretty much guarantees you're going to have major issues because you did not satisfy the problem gods throughout the manufacturing process. If the yellow is the PWM output and the purple is on the rail of that PWM output at the MOSFET, and they are both set to the same 5-volt degree here, why is the MOSFET lead not receiving any voltage? It should be the same size, should it not? Yes. Well, that's a real oofda because I had the adjuster set to 10x reduction rather than 1x like that one, so now they are the same. So now we are getting signal to the MOSFET. That's a known fact. I might be an idiot because these are reversed here because I reversed that, which I thought was already reversed, but it wasn't, so that's my whole problem all along, so I got to reverse these two terminals. Alright, that was exactly it. My originals had, for some reason, polarity reversed on the input on these things, which also had made me have to reverse the polarity on this MOSFET. And I remember maybe mentioning something about it to myself. I'm like, I'll fuck with it later. Well, it came back to bite me because this was definitely the case when a simple diode replacement turned into discovering this thing, which also turned into discovering this thing, which also turned into a whole mess. So we are set again here. We have proper G, D, and S as appropriate, drain and source color coded as they should be. So we're going to slap this thing back together and continue on. I wonder if my MOSFET's still good. Testing. I hear the transformer and I don't see massive amp usage, so I think we're good.
This is Stand Revenge.
Now back to our regular scheduled programming. Good lord. Alright, connected again. That's more acceptable amp usage. We can get you up to 20 volts easy just on one single 6-cell. Pretty interesting waveform. A little bit more amps than I want to, but we are finally again getting production. Thank God. So real quick with this VIC here, pumping it at 860 hertz at only 18% duty cycle. If I can crank this puppy to max, get good signal. This is a waveform I'm getting right there. And I am getting appropriate production for that voltage level. Getting 19 volts on the cell, only 150 milliamps traveling through that cell. At 3 amps at 29 volts, less than 90 watts of power. 2 6-cells in series now. Let's look at that previous waveform real quick. Yeah, only 18% duty pulse on that. Look at that residual voltage potential in that cell between those two terminals. Noted that voltage is highest when it goes down to 18% duty pulse. As you increase duty pulse from there, voltage drops on the cell. I'll show you right here. We'll do it at yo, what? Oh, we're 40 volts because we have 2 cells hooked up, yeah. Nice, can we go higher? So we're kind of capped at 40 volts there. Amperage is down from 150. Still same waveform ish. Only consuming 2.7 amps now. Weren't we previously at like 3 or 4? Valve check, very important. Valve was closed. Bad. So as previously seen before, more cells, more production, more voltage, less amperage on the cell, and less amperage consumed. And with duty pulse down to less than 20%, that's impressive. Getting some fair production here. $43 volts at the cell, 74 milliamps consumption. Waveform. See my except my amp meter is bugged out here. One sec. Now let's see what she's cooking. A little better. Damn, we got to 45 there for a sec. This waveform is crazy. Consumption here. Doesn't want to get much higher than 40 or 41 volts. Alright, as a test here, I have removed my secondary inductor altogether. I have a bridge. So all I have is a primary, a bifilar secondary center tap, and this one inductor right here. We still get a similar waveform, and we get production, and I mean, more or less works the same without the secondary without inductor B. Therefore, SOS Productions, follow him on YouTube, brought up a very good point about this electrical ground J. Now, through my findings, if you have a secondary coil wound bifilar and you're putting pulses into it, not AC, but pulses, you will get both a positive pulse and a negative pulse generated at the same time with a bifilar center tap coil secondary. I've proved this in my work, reference my previous videos. So if that is the case, this right here, this may be the secondary bifilar's negative coil. Given this is electrical ground J, being like the center tap of that, this is part of the secondary transformer. Therefore, if we combine these two into one coil, so we have this secondary positive coil, the secondary negative coil with the center tap being right here, essentially. We're moving this thing basically here. We need to have this coil match this coil, being our two resonant charging chokes, need to be essentially the same, but since these are bifilar wound together, this is going to have a different value than what this one is. Therefore, this variable inductor is used to balance this equation to make sure that the inductor here and the inductor here are balanced equally. But if this is the secondary's negative coil on the opposite end of the center tap, all this needs to do probably be very small just to adjust that. I recently took this coil out altogether for my cell and I got pretty much the same performance. So by essentially eliminating this and just using this as a variable inductor to get this and this to match, but this being bifilar wound, one for the positive rail, one for the negative rail, it's going to have a different value. So we need to wind this to match this, but also have this to adjust it, fine tune it. It makes sense. I write to him, wow, what a fresh perspective. Center tap at electrical ground J makes perfect sense because the secondary bifi coil also provides equal opposite polarity pulses. That's what I was talking about. A bifilar wound secondary coil pulse with a positive pulse will produce both a positive and negative pulse simultaneously. Perhaps I need to balance my center tapped secondary's bifilar negative coil to match inductor A. So inductor A should be the same value as the second bifilar coil on this transformer here. These should be balanced. This is going to be a very small coil variable to give it just a little bit more or less inductance to balance this circuit out. Makes perfect sense to me, and I would love to give it a try here. In reference here, you know, primary coil and our secondary coil is going to be bifilar wound. There's going to be two wires wound, but it's going to be center tapped. So the positive here is going to be connected to the negative here. This is essentially like 0 volt. Inductor A here, being in series with this, is going to create a resonant scenario. But to match this on this side, this being a negative pulse being generated, positive pulse being generated here, this blocking diode here, this inductance here needs to match this inductance here of this secondary's bifilar coil. You can see that I've got it in green and red to basically indicate that it is the secondary's bifilar wrap, but this second coil here is the inductor and it needs to match this inductor here. So it can be wound as closely as possible, but the variable inductor here is literally just to fine tune it. It does not need to be 3 separate ass coils that I normally have, 1, 2, 3. It's literally 2 coils matched with a variable inductor to just fine tune it. It makes perfect sense, and I'm gonna give it a try.
This is Stand Revenge.